What's up, YouTube? In this video, I'm going to look at the power output of the Liitokala HG2 cell versus some other 18650 cells. So here we have the HG2, and I'm going to compare it to the VTC5 from Sony, along with the Golden Dragon from a generic Amazon power cell I bought, and then a couple generic laptop non-power cells, 2 amp hour and 1.8 amp hour shown here, and then also a Samsung 1.5 amp hour power cell. The resistor I created to draw the amps from these cells is a homemade one from several coils from a space heater looped through in this fashion. It's kind of crude, but it supplies a 0.175 ohm resistance to the cells, giving me roughly 20 amps at the most on the best power cell. The amp load is high enough that I have to run it through a shunted amp meter shown here. So the resistor, as you see here, feeds into the shunt. Polarity shown at the bottom, and then the meter itself detects the amperage off these two leads that run off the shunt. My setup also has a voltmeter due to the voltage not being very accurate off that voltmeter on the shunted amp meter. A thermocouple shows the temperature, and then I also have a timer to show how long that the cells run before the voltage drops below my cutoff of 3.2 volts. So here the Liitokalas are the first to be tested. You can see how fast they fall under 3.2 volts. The first one lasting less than 10 seconds. This second one here will last just under 1 minute. It's supplying at most 18 amps. This one here, 3 seconds before it falls under 3.2 volts. And this one here, slightly better, almost 30 seconds. The Sony VTC5s fare much better, lasting over 4 minutes and providing much more power than the Liitokala HG2 cells do the entire time. You can see here the second cell supplies nearly 19 to 20 amps the entire time and lasts almost 4 minutes to 3.2 volts. The Golden Dragons quickly fall in voltage, but they do last nearly just as long as the Sony VTC5. So although they don't provide the power that the Sony VTC5s will, they do however last almost as long at the lower power output. You can see here these last a little over 3 minutes. The Samsung 1.5 amp hour cells last about half as long as the higher capacity power cells like the Sony VTC5s and the Golden Dragon cells. Not great, but not nearly as bad as the Liitokala HG2 cells. For humor purposes, I figured I'd test a couple non-power cells sourced from generic laptops with low nominal capacity. The thermocouple was basically a waste of time since these things will not supply hardly any power for any amount of time. As you'll see, they immediately fall below 3 volts and continue to plummet, supplying at the very most 15 amps, which quickly dies down, showing that they have no ability to supply any amount of power. The 1.8 amp hour cell fares slightly better as far as how fast the amperage and voltage fall. Again, wasting my time putting a thermocouple on it. and you'll see below 3 volts before I can ever start the timer. Supplying at the most a little over 14 amps. Removing the load, you see the voltage immediately recovers, suggesting how resistive these cells are and ill-suited they are for power application. The chart here shows the power in watts output over the time frame that I've tested them, and you can see the Sony fares the best out of the group, lasting nearly 250 seconds, with the Golden Dragons trailing slightly below it, outputting lower power but lasting almost as long. The Samsung falls roughly at the midpoint, supplying less power though during that, and the Liitokala is supplying much less power for hardly any time, with the best 2 cells lasting roughly 50 seconds. Temperature readouts is kind of a wash. The longer the cells would supply power, the hotter they got. So the poorer cells kind of didn't have time to jump up in temp, and the better cells had much longer time to increase temp. I hope you enjoyed this video. Thanks for watching, and I'll see you around.